Hi everyone, I'm Chenfei from MSI NOC Group. Today I talk about VLP training for high-resolution visual synthesis. In this page, I will give a brief overview of related works. Firstly, I will introduce gain from global latence or from coordinate latence. So the gain from global latence has drawbacks of generating repetitive results. And from coordinate latence work, they can generate non-repetitive results that have rapid transition between patches. And NAR models like mask GIT can generate results with smooth transition between masks. Then I'll use AR-based model like timing transformers that generate tokens, token by token. So it can generate results with smooth transition between tokens, but it relies on sketches. And then I'll introduce diffusion models. So diffusion models generate the result from vague to clear. However, it can only generate fixed size results. Some other work like super resolutional models are a two-stage model. They first generate a low resolution image and then use a super resolution model to convert the low resolution image into a high resolution one. However, they can only generate fixed size results. And finally, I will introduce autoregressive over autoregressive work. That is our new work called Nuwa Infinity, which can be used to generate infinite size results, including infinite size images and infinite size videos. Local gain generates different patches with the same global latence, which limits the diversity and leads to repetitive results. To address the repetition issue, ALRS generates different patches with different coordinate latence. However, this sometimes brings rapid transition between patches when the coordinate latence are too different. Autoregressive models are naturally beneficial for generating smooth transition results. Timing transformer views images as discrete tokens and generate a high-resolution image token by token, which considers the smooth transition between nearby tokens. As a result, it fails to model long-range consistency and has a slow inference speed. Mask GIT generates mask tokens based on visible tokens inside a sliding window. The inference speed is improved by generating mask tokens in parallel in fixed steps. Although it considers a smooth transition between the generated mask tokens, it still fails to model long-range consistency. DDPM is the first work to explore the possibility to apply diffusion models to higher quality image synthesis. It connects the diffusion models with denoising score matching with Langevin dynamics. It is flexible and only depends on sampling from the noises. This is the architecture of Dolly. It has two stages. In the first stage, it trains a discrete variational autoencoder, or VAE, to compress each 256 times 256 RGB image into a 32 times 32 grid of image tokens, and each element has 8,192 possible values. And in stage 2, they concatenate up the 256 BP encoded text tokens with the 1024 image tokens and train an autoregressive transformer to model the joint distribution over the text and image tokens. Dolly is able to generate diverse images by the description of the text. Different from Dolly, Nuwa is a unified multimodal pre-trained model that can generate both images and videos. and Neural achieved this goal by designing a 3D transformer, encoder, and decoder framework. The first task is text-to-image generation. For example, a wooden house sitting in a field. Neural generates a diversity of results. And the second example, a young girl eating a very tasty-looking slice of pizza. Or walnuts are being cut on a wooden cutting board. And you can see the results are very realistic. So Neural achieves a significantly high FID score of 12.9 and outperforms 27.1 of Dolly from OpenAI. The second task is sketch-to-image generation. That is, you input a sketch and you ask the machine to generate the image that is consistent with the sketch. So Neural generates a diverse, realistic results, and even the reflection of the bath window is clearly visible. The third task is image completion. That is, you input part of the image and you ask the machine to generate the left part. For example, if you input the upper part of a tower and you ask the machine to imagine what is the lower part of the image. And Neural shows strong imagination, and you can see it can even complete an image with only 5% tokens. It's image manipulation, and Neural can add, remove, or change any parts of the image to whatever you want. The fifth task is text-to-video generation, and Neural can generate unseen videos like running on the sea. This is a sketch-to-video task, and Neural generates temporary, consistent open domain videos. And this is a video prediction task. That is, you input the image and ask the machine to predict the future frames. The Neural predicts the future of the image, and it predicts for many images, like human faces or landscapes. And in the last example, it is an interesting example, and it shows a coffee face, and Neural just animates this face. Is video manipulation, and Neural can manipulate video filters with the control of the language. This is the architecture of Dolly 2. Dolly 2 incorporates a pre-trained clip model. It consists of a prior that generates a clip image embedding given a text, and then a decoder that generates an image conditioned on the image embedding. Based on the design, Dolly 2 can generate many interesting results. This image shows the variance of an input image by encoding with clip and then decoding with a diffusion model. The variance preserves both semantic information like presence of a clock in the painting and the overlapping strokes in the logo, as well as stylistic elements like the surrealism in the painting and the color gradients in the logo, while varying the non-essential details. Imaging, the language model, which uses Google's own T5XXL. During the training of imaging, the text encoder is freezed. The image generation part is a series of diffusion models, which generate low-resolution images, and then oversampling them step by step into a bigger one. The biggest advantage of this is that the pure text training data is much easier to obtain than the higher quality graphic data. The C4 training set of T5XXL contains 800 GB of pure text corpus, which has more data than clip. In human evaluation, imaging performs better than Dolly 2, Glide, VQ Game plus clip or latent diffusions in terms of fidelity and semantic element. Experimentally, Google also found that expanding the scale of the language encoder of imaging has a greater impact on the final results than expanding the image generation part. If we see the recent works, we will find that higher resolution becomes the new trend. DOI is able to generate 256 times 256 resolution images based on text. Nuwa extends DOI from images to videos and supports generating both 256 times 256 images and videos. Recently, DOI 2 from OpenAI and imaging from Google is able to generate high-resolution images with 1024 times 1024 resolution. In the following, I will introduce our new work, Nuwa Infinity, which is able to generate infinite resolution images and videos. Why infinite resolution important? It is well known that high resolution means more details. Compared with the resolution of 64, the coconut tree of a resolution of 256 shows more detailed leaves. But higher resolution implies more than that. For the same fidelity, an image with 1024 times 1024 shows wider views. This shows high resolution implies not only more details, but also wider views. In this page, I will provide a brief comparison between Nuwa Infinity and existing works. So, existing models, including CockView, DALL-E 2 from OpenAI, or imaging from Google, they'll use a two-stage pipeline. In the first stage, a render model is used to generate a small image. And in the second stage, a super-resolution model is used to resize this small image into larger one. The drawbacks are obvious. They can only generate fixed-size images with limited resolution, and it supports images only. To solve these issues, we propose Nuwa Infinity, an end-to-end solution. The idea is simple. Input a text, a context-aware rendering model is used to generate a patch, and then the patch is fed to the context pool to help the next patch generation. The iterative way has great advantages. You can generate any size, any resolution you want. If you want to generate a larger image, you just run it for more steps. As a result, Nuwa Infinity is able to generate arbitrary sized results with infinite resolution. Also, it is very easy to extend to videos in this pipeline. Videos can be simply viewed as adding some temporal patches. Here is a more formal architecture of Nuwa Infinity model. For example, if you want to generate a 13th patch, the surrounding patches, including the 7, 8, 9, and 12 patch, and the behind temporal patches, are pulled from the context pool. Then, with the guidance of an optional text prompt, the rendering model renders the 13th patch, and finally, the 13th patch is pushed into the context pool to help the generation of the next patches. Actually, there are plenty of details. For example, the input and output strategy and the context pool should consider the patch orders. Nuwa Infinity supports multiple downstream tasks, including unconditional image generation, image extension, text-to-image generation, and image-to-video generation. So, the first task is unconditional image generation. This is an image generated by Nuwa Infinity with a resolution of 1024 times 2048. Actually, it is the first image generated by Nuwa Infinity, and personally, I use this image as my desktop wallpaper, and I like the consistency between the clouds and the reflections. Here, another example trained on design dataset, and we can see the abstract beauty of neural infinity. One may have a question, what is the meaning of unconditional image generation? That's why I put this example here, the famous painting, the Riverside scene at Qingming Festival. It is not painted by Zhang Zeduan. Instead, it is painted by neural infinity. We can see the details here. Imagine the scenario. I want to draw the Riverside scene at Qingming Festival, but I do not know how to draw it. So I learned from Zhang's painting day by day, and finally, one day, I can draw it with my own imagination. Here, unconditional does not mean uncontrollable. The machine is learned from Zhang Zeduan. The machine will generate patterns similar with Zhang's habits, Zhang's tastes, and Zhang's styles. And this result is unique in the world. It has similar patterns with Zhang's version, but it is totally different. And you can see the quality, the poses, and the expressions in human faces are very clearly shown. Let's come to the second task, image extension. Input an image. Neural infinity is able to extend it into larger ones. The left is the input, and the right is the output. And you can see the rain, the leaves, and the style is very consistent. This is a Windows wallpaper, and we try to extend it into an extremely long one. And it's right. You will see beautiful lakes, clouds, seas, and trees. The Starry Night, one of Van Gogh's most famous works of art. By using neural infinity, we can extend it in all directions to full screen, smooth and natural. This shows the great generalization ability of neural infinity, since we never trained on paintings of Van Gogh. But it still understands its styles. The Gleaners by French artist Millet, 1857. We can extend the sky and the grounds to show a wider view, and you can hardly find the borders, and the styles are very consistent. I also tried an interesting scenario, like I want to modify my own photo. I want neural infinity to guess my surroundings based on little trees behind me. It seems I'm in a wild forest. Actually, we can generate many forests, and I just need to choose which one I like. So the third task, text to image. Input the text, a road that is going down a hill. DOI is able to generate 256 times 256 results. For neural infinity, 1024 times 2048 resolution makes it more realistic. Even the lights, the shadows can be clearly shown. Here are some other generated results based on different text controls. You can generate a common forest or a forest with fogs or snows. One may ask, are these results really generated, or are they copied from the dataset? We carefully checked on this. For a tree with no leaves, I compared personally one by one in the dataset, and I can guarantee that the generated results are unique in the world. We also try on a design dataset by input some abstract colors and ask the model to generate the background. Here comes the image to video task. Input the left image, and neural infinity successfully animates it. So this is the result with 18 frames, and you can see it moves very smooth. It can not only generate the waves, but also the camera movements. Here is another example which generates an abstract file. The final task is text-to-video generation task. This is an interesting scenario. Input a story and you ask the machine to generate a cartoon for this story. For example, you input Fred wants to find the trader, and he drives the car, he passes some trees, and he stops at a cave. He goes inside, and Fred finds the trader, and finally, he's very happy. In following, I would like to discuss the future of visual design. With a powerful AI ability, I think that Neural Infinity will help the designers to co-create better works together. Next, I'm going to use 4 cases to show the application scenarios of Neural Infinity in the design industry. In the first case, a designer often makes a lot of creative graphics. Elements such as objects, color, and style of the idea even are already in a designer's mind. However, it still takes a lot of time and effort, like searching materials, brainstorming, sketching, and use software to realize it. How to better inspire ideas and transform it into visual works more efficiently? Using Neural Infinity's technology, we only need to input the text of the idea, and Neural Infinity will quickly generate multiple creative pictures of different styles, and you can also expand the pictures as you want. The graphics generated by Neural Infinity have a very high quality sense of design and can meet the needs of multiple scenarios, such as background of desktop, mobile phone, PowerPoint, and you can also print it with high resolutions on the wall as an artwork. The second case, sometimes we have a designed graphic like the left cover of our magazine Matrix, and then we think about how to make it motional. Because the motional graphics are more attractive and imaginative for users. Using Neural Infinity, we can easily animate it. Although it is not the perfect, but you can see that Neural Infinity is trying to understand the structure and the shape of the object in the picture. The motional graphics and posters not only support better promotion and communication, but also can inspire designers to better present his or her creativity. In case 3, I want to put the car advertisement on Bing, but need to make the original photo adaptive on different web pages. Through Neural Infinity, images of corresponding height and width can be generated according to the needs of different sizes. You don't need to crop the pictures anymore. And the last case, for example, when someone in a Teams video meeting and he opens the camera, he likes to set up the background image. And the image is beautiful and fancy, but it always makes him feel unnatural and fake. If we can animate the background image or the video naturally, and we improve the user experience of the Teams meeting. Now, we are still exploring the possibility of Neural Infinity in other application scenarios, not only for professional designer, but also for more users who want to participate in creative design or artwork, such as the restoration, virtual scenes of gaming, generation of storyboards in prototype design or movie industry, choreography. At last, let's imagine that if AI technology like Neural Infinity can help disability people to design and create with friendly interaction, I think it will be more meaningful. Thank you.